Okay, good evening. Let us start. So yesterday we have solved this one, and it was for wave equation. Okay, wave equation for the string which was tied with the two rigid ends. So we have got this wave equation, and this u is representing here. Here u is representing the displacement. In wave equation. Okay, so this is the displacement in wave equation. Wave equation we have taken del to x, del to u by del x square is equal to 1 by c square del to u by del t square. This was our wave equation. Okay, or we can write it, because double differentiation we can write u double x, that's it. Equal to u double t. This c square I am writing here. So this was my wave equation. Understood? Here t is what? T is the time. T is greater than 0. And x value is zero to L. These are the two conditions we have taken. Okay. So here for generalization, in general, because we know sometimes this velocity is not always the velocity of light. If it is, if the wave is going through the vacuum, then we take velocity c. Okay, suppose light wave is going through vacuum, then velocity we take c. If it is going through some medium, okay, so that time this velocity can be also v. So neither c neither v, I am just taking this as a. Suppose this is a. So in general we can write it a square uxx equals to utt. So if this type of wave equation you find where time is greater than 0 and x value is between 0 to L, so then in general this is your wave equation. In general, for wave equation, for this wave equation, my answer will be uxt will be equal to summation n equal to 0 to infinity. This is same my answer. In place of c I will write a an into cos an pi t divided by L plus bn sin n pi an pi t by L into sin n pi x by L. Now if you check here, initially we have taken uxt equal to x into t. So this complete function work as function of t, and this complete function work as function of x. So uxt is nothing but xx into tt. So this is the same thing. Understood? So this formula you must remember. If you want to solve the problem in exam very quickly, so this formula you must remember. You will start from here only. If this type of equation is given, this also you remember. So this is the wave equation. So in general, if the wave equation is this type, so solution of that will be this type, and they will ask you solution only. So in that some condition they will give, that condition you can apply and you can get the answer. Okay. Now, because till now we have taken only two boundary condition, so I need two more boundary condition here to get the value of an and bn. So suppose two more boundary condition are given. Number one, u, or you can say that it will become 3. Third, 2 already gone. Okay. Number third is ux0. In place of t, you take 0. So this is the initial time. This is the value of u at any position x, but starting time is 0. So this is known as initial displacement. Initial displacement. Okay. This ux0 value will be given as, because t is not there, so that will be purely function of x. So we can say that ux0 is nothing but pure function of x. One more condition can be given for the initial velocity. This is initial displacement. If I differentiate this, it will become initial velocity. So fourth condition is my initial velocity. And that initial velocity, how I can get? Differentiate this with respect to t. So ut, it will become ut. Del u by del t is ut. x0 will be equal to, so it will be another function of gx, but because this is we are getting from differentiation of that, so that's why it will be another function of x, that will be gx. So it is initial velocity. Okay, you must understand here that ut is del u by del t. For that I am writing ut. Okay, so note down this. Done.
Yes, sir.
Today they have given odd timing. Okay, so many students might not be aware of that. Okay, no problem, they will see the recorded video. So okay, so now what is our next step? Now we will apply the boundary condition. Applying boundary condition, ux0 is equal to fx. Okay, so in this equation, in this final equation uxt, you put t equal to 0, so then cos 0 will be 1, so only an is remaining from here. Sine 0 will be 0, and sine n pi x by l will be remaining. So fx will be equal to an Summation is also there. Summation n equal to 0 to infinity an into sine n pi x by L. Okay, so this is the value of fx. So like this you can find out fx. Understood? Now actually this type of series now you will find in Fourier series. So in Fourier series you will find this type of series, and in that series there are two constant an and bn. To find out an, different trick we have to use, and to find bn constant, different trick we have to use. But in Fourier series you might have seen that we are using the direct formula of an, direct formula of bn. But from where they are coming, okay, that we are going to learn here. So this partial differential equation, definitely it will have one question in the NET exam, GATE exam. Okay, so instead of that you will find it very helpful when you are solving such partial differential equation, whether in quantum mechanics, in Schrodinger wave equation, or in AMT. Okay, so this will be very, very useful if you know this. So you have to learn it very well. Little bit difficult it is because we have not practiced it many times. Okay, some of them, some of you might be learning it first time only. So that's why. But it is easy if you practice it. So applying the boundary condition here, this you have got. Okay. Now in Fourier series, okay, that Fourier series can be sine series, cos series. Okay, all are available in Fourier series. To find an constant, there is a trick. What we do, you multiply both sides of this equation with this term. This term is sine n pi x by L. Okay, so in Fourier series, to find an constant, multiply this equation by sine n pi x, sine n pi x by L, both side. Okay, both sides, and then integrate it. Okay, so left hand side it will become integral 0 to L fx into sine n pi x by L dx. That will be equal to integral 0 to L an into, this will be sine n pi x by L into again sine n pi x by L. So it will become sine square n pi x by L dx. So this summation now actually my limit of wave is from 0 to L only. Understood? So that summation will be converted to integral and this will become this much. So an is constant, it will come out. Now from here, integrating this side, this fx will be given in the question. So as per that we can take that fx. Understood? In the boundary condition it will be given in the question, but as per this condition ux0, this fx is coming from here. Okay, but when they give this condition now, fx will be given something. That's something we have to take on left hand side. Okay, so examiner will give this fx, but from our formula we have found fx equal to this much. So the both can be equated. Now here an will come out. Now tell me, this will become 0 to L. If I take it 1 by 2 into, it will become 2 sine square n pi L n pi x by L dx. Now 2 sine square theta can be written as in terms of cos. what we can write? It will become an by 2 into 1 minus cos 2 theta is equal to 1 minus 1 plus 2 sine square theta. So 1 minus 1 is 0. So 2 sine square theta can be written as 1 minus cos 2 theta. So it will be integral 0 to L 1 minus cos 2 n pi x by L dx. Okay. So an by 2 into, it will give you, integral of that will be x. Limits are 0 to L. And minus integral of this will be a sine term. This I can rub if you have no. Okay. So it will be a sine 2n pi x by L and into 2n pi, sorry, it is integration now, so it will be division 2n pi by L. Okay, and limits are 0 to L. So once you put L to L cancel, sine 2n pi, that is also 0. Once you put 0, that also 0. So this term goes to 0. So only this term will give you L minus 0 L. So answer is an by 2 into L. Okay. Now you want to find out AL, that is equal to integral 0 to L fx sine n pi x by L. So from here in the sine series, this formula we directly use. You can check it. Okay. So an will be 2 by L integral 0 to L fx sine n pi x by L dx. So this is the value of an coefficient. Okay, so note down it here. Done.
Done, sir.
Yes, sir.
Okay, note down this also quickly.
Done, sir.
To find Bn, we use a different trick. What is that trick? You have to differentiate your main equation. Which is your main equation? This one. Suppose this equation is 1. So this equation you have to differentiate with respect to time. So sine n pi x will be same. You have to differentiate this with respect to t only. So this cos will become sine into an pi by L will be there minus sine an pi t by L into an pi by L, and this will be plus bn into cos an pi t by L into n pi by L. Understood? So that I will write. then it will be ut. Okay, because my second condition is that, because I want to apply the second condition. Second condition is what? This one, ut. Ut means it is del u by del t. So del u by del t I have to achieve first. So from that, if ut x0 is given, that is a gx function. So for that, I can find out the bn value. So remember, to find out bn, we must have gx condition. To find out an, we must have fx condition. Fx means ux0 condition. So I'm doing the same thing. To find bn, first of all, we have to apply fourth condition. So we differentiate equation 1 with respect to t. So what we will get? We will get ut xt. This side I can write del u by del t. So that will be ut xt. That will be equal to summation n equal to 0 to infinity. Now minus of an into an pi by l. It was supposed now, so it will become sine an pi t by l into this an pi t by l I have written already. Okay, then plus bn into last portion was sine, so sine will become cos, and an pi t by l also will come. An pi by l will also come, and that will become cos an pi t by l. And outer portion is similar because that is not having t, so it will become n pi x by l. Okay, easy. So now here you can apply the condition at t equal to 0, because condition is ux0, utx0. At t equal to 0, this utx0 will become, it will become gx. It is given. It means my function is gx. Now here also you apply 0. So this first term will become 0. Understood? So here an will go. Only bn is remaining. So that's why to find this bn, you have to apply fourth condition. 1 second. Hello. Hello. Okay, so gx will be only bn will be there, summation n equal to 0 to infinity bn into an pi by l into cos an pi t by l into this sign also, sine n pi x by l. So this will be the value of gx. Now again, what is the trick? Multiply this value. Multiply this value by both sides and then integrate. So just to find bn, everything is going on. Multiply both sides by sine n pi x by l and integrate. Note down this.
Done, sir.
Okay. So we have to multiply it. So it will become, left hand side will become integral 0 to L gx into sine n pi x by L dx will be equal to bn into a n pi by L into integral, 1 second. So this summation also will be converted and my limits are 0 to L. So that will become sine square n pi x by L dx. So again, this is the same thing we have done just now only. So answer for that was integral 0 to L, this one, integral 0 to L sine square n pi x L by 2, this one, integral 0 to L sine square n pi x L by 2. The final answer is L by 2 only. From here it will come L and this will give me 2. 2 is also taken. Okay. So final answer is L by 2. So that I am taking directly. And here, so this is the term which will be integrated and these are the, this is also there. 1 second. Because this gx is at this now, so this will be cos 0. So here it will be 1. So 1 means it will be gone from here. Understood? Because here t I am putting 0. So cos 0 will be 1. So only this much is remaining. So this much is remaining and this value will be L by 2. So bn a n pi L L by 2. That is equal to 0 to L gx sine n pi x by L dx. So from bn can be find out now. Bn will be this L to L cancel. So it will be 2 by a n pi into integral 0 to L gx into sine n pi x by L dx. So this is the constant and here gx will be given in the question by the examiner. Okay, so like this you can find out the different both the coefficient. Okay, so these are the methods utilized in Fourier series, and in Fourier series an, bn, a0 we directly find by using this formula only. Okay, note down this. Done?
Done, sir.
Okay. Okay, so now till now what we have done, that I will summarize. Finally, for wave equation a square u double x, so this is del u by del x square equal to u double t, where x is in between 0 to L and t is greater than 0. Okay, and it is 1D undamped, one dimensional. This is undamped equation. Damped equation I will solve separately. Up to now it is undamped, because for the damping we have to take one more extra term that we will take afterwards. For 1D undamped equation, this is 1D undamped equation. And in this type, we have learned that our string is tied between 0 to L like this. And when we displace it, it will make a wave like this. So for this, solution is UXT is equal to summation n equal to 0 to infinity an cos an pi t by L plus bn sin an pi t by L into sin n pi x by L. So this you must remember because it will be utilized whenever you have to solve the problem. Okay. Now in that there are two boundary condition that ux0 will be taken as fx. So fx will be given in the problem and utx0 will be equal to gx. Now you have to think, if gx is not available, so it means bn will not be available. So bn will be 0 because bn is only find out by gx. So if gx is 0, so then bn also will be 0. It means this term will be cut from this. So simply you can take uxt equal to an cos an pi t by L into sin n pi x by L. So this term will be gone. If fx is not available, so then an will not be available. So that time uxt will be bn sin n pi t by L into sin n pi x by L. Understood? So like this, you have to, this much skill you should have. If someone of them is not available, so then which one of coefficient will not be available? Okay. Now, one special case we have to take here for this. A special case. If in the question, if in any problem, gx is equal to 0, it is given. Okay. If in any problem gx is equal to 0, so then by D'Alembert formula, we can write uxt. Uxt we can directly use by using the D'Alembert formula. Then uxt will be, because only fx is available, so in that fx, half of f x plus at and plus f x minus at. So that much you have to do and then you will get the uxt. So this formula is also very, very important. If in some problem gx is not given, gx is equal to 0, so directly you can find out uxt. No need to use any other thing. But fx you have to find similar kind. Fx is your ux0. So where is the fx? This is your fx. So fx will be directly this much, and from here you will find out the, or fx will be given in the question. If fx is given in the question, that fx you can utilize very well, no problem. So in that fx, just half of fx plus at plus f x minus at. That much only you have to do. That's it. You will find the answer. So this formula is also important, but you have to notice that gx must be 0. Then only this formula is applicable. Otherwise, no. Note down this. And here f is, I already told you here, fx is initial displacement. u x0. So this was the fx. Note down this.
Sir, if in any question if gx is not given, then
If in any question gx not given, no, he will
gx
tell you.
is
He will tell you. He will tell you gx is 0. Okay. Or if it is available, then he will give you. If it is 0, then also he has to tell na. Clearly it will be mentioned. No ambiguity will be there. I will give you one exam problem. Okay. How the question came in exam, I will give you that and you have to solve. And you will find that it is very easy.
then
Okay. So let us take one exam problem. Question is for 1D undamped oscillator. Remember, undamped, it is undamped, no damping. For damping, there must be gamma value. Gamma we are not taking here. So this is undamped. For 1D undamped oscillator, oscillator means it is creating the waves. They have given this picture also. This is x equal to 0 and x equal to L. And these are the waves created. Okay. So for this, they have given fx. Fx equal to ux0. That is equal to e to the power minus x square. So fx is given and gx is equal to 0, where gx is ut x0. So this is given already. Okay, find uxt. So what will be better to use? So better to use the D'Alembert's formula. That is simple, easy. No need to remember anything. So just take this fx and put it in the D'Alembert formula. Okay. So because gx is 0, so by D'Alembert formula, uxt will be what? Half of f x plus at plus f x minus at. Okay. Now half of fx plus at means fx is e to the power minus x square. In place of x, you have to write x plus at. So it will be e to the power minus x plus at whole square plus e to the power minus x minus at whole square. So this is the answer. Now I can tell you, sometime he can give you the equation. Suppose he has given you the equation for equation 9 into u double x equal to u double t. For equation this, fx equals to e to the power minus x square and gx equal to 0. So these are the things given. Find uxt. Suppose this is the question. So what you will do, everything is same. Now this equation, if I, because this thing I have taken here in this my general form of equation is a square uxx equals to utt. So you can compare this. So a will be here, a square is 9, a square is equal to 9. This implies a is equal to 3. So in the same thing, because everything is same, fx is given, gx is 0, so everything will be same. You will use the D'Alembert formula. So then directly you can say that uxt will be 1 by 2 e to the power minus x plus 3t. Just a you have to replace, and plus e to the power minus x minus 3t whole square. That's it. So like this, extra mind you have to apply if some value is given. Then a you have to find out. Note down this.
Done.
Okay. Okay. So if I give you one more question for 1D undamped oscillator. So once it is given 1D undamped oscillator, so you have to understand that this is same equation. A square u double x equal to u double t. That is the same equation, the same wave equation. Okay. No need to give anything. Given fx is sin x and gx is 0. Okay. So then find uxt. This is also similar kind of question. So here also by, because dx is 0, so by D'Alembert formula, uxt will be half of, just directly you can use sin x. In x you have to use x plus 80 and plus sin x minus 80. So this is answer. Like this you can solve. Okay. So one more question I will take. That question I will solve by different method, and you can cross check it by D'Alembert method. Understood? So by using the D'Alembert method, that is very simple. Okay, directly you can use whatever the fx is given in the question. In that you can put x plus 80 and x minus 80, add them and just take half of that. So you can do it easily. But I will tell you by the conventional method also. Sometime, because it will give you the skill. It will give you the thinking power. Okay, how to solve the problem. Sometime if you forget this formula, so then you have to go through the conventional method only. So for that time, that skill will be utilized. So I am giving you that question. So D'Alembert method, you have to solve it. It is simple. Then you have to match your answer with the conventional method. By conventional method, I will do this. Okay. For wave equation 9 into u double x equal to u double t. Here the limit of x are 0 to 5. Now remember there that value of L has been changed. Value of L is 5 now. Value of A is 3 now. That also you have to use. Okay. And they have given u 0t is equal to 0. So this is your condition. We know it because our string is in between 0 and 5 now. X equal to 5 and x equal to 0. And what is telling? u0t means value of displacement. Here remember always uxt is the displacement. For displacement we are using this u value. Okay. So u value. So this is the displacement profile. Profile of displacement will be given by this function u. So u at x equal to 0 is always 0 because these string are fixed. So here no displacement will be there. Here also no displacement will be there. So one more condition will be there, u 5t. u 5t is also 0. Means at this place also your displacement is 0. And t is greater than 0. This is also the condition. One more thing they have given, ux0. So this is the value of fx. So ux0 is given. They have not written this fx, but you have to think that this is fx only. Okay. So ux0 is, they have given 4 sine pi x minus sine 2 pi x minus 3 sine 5 pi x. So this is a lengthy function given for the ux0. Here in the question it is not given, but I am telling you that this is fx. Now ut x0, that is equal to 0. Now tell me what is ut x0? fx gx. So my gx is 0. It means here directly I can apply the D'Alembert formula, simple formula. So here what you have to replace, just your uxt will be half of this whole formula. In that you have to put x plus 80 in place of x. Then again plus in the whole formula you have to put x minus 80. And in that you have to apply the because 3 terms here and 3 term before, there will be total 6 term. Now they will be x plus 80 and x minus 80. So x plus 80 is sin a cos b. Sin a plus b is sin a cos b. Like that you will expand that. This also you will expand. This also you will expand. Again for this term x minus 80, sin a minus b will be sin a cos b minus cos a sin b. Like that you will expand this term. Total there will be 12 terms. Out of that 6 term will be cut. So only 6 term will be remaining and they will be added, and finally you will get only 3 terms. I am telling you everything. Okay. If any difficulty, please tell me. I will solve it, no problem. Otherwise you can solve it with the help of D'Alembert method. But conventional method, with the conventional method I will solve it. Note down this.
Done, sir.
So here question is find U60 solution. Okay, by D'Alembert method. This is your homework. You have to do it and verify. Okay, by conventional method I am solving it. So by conventional method, how we can solve it? We have to use the same formula first. Okay, so by conventional method, this type of wave equation will have solution. Because we have to recognize the wave equation, then we have to apply the formula. So this type of wave equation have uxt equal to summation n equal to 0 to infinity. That's why it is must to remember an cos, or actually here we can compare this type of wave equation have the solution this. One more thing I can have here, comparing wave equation by, so this equation I can put 1, so wave equation 1 by my standard equation a square uxx equals to u double t. So here a will be equal to 3, okay, and L will be equal to 5, because here this expression is 0 to L, but here it is 0 to 5. So L is equal to 5, A is equal to L. So everything I will replace. L by L I will replace by 5, A I will replace by 3. So that one step will be saved. Okay. So it will become An cos n pi A n pi t. A in place of A I am writing 3 n pi t by L. In place of L I will write 5 plus. So Bn I can leave. Why? Because Bn will go to 0, because Gx value is 0. So Gx value only give me Bn. So Bn I will not take. And I will write at the last, because Gx value is 0. So Bn also will be 0. So I am not using that. Okay. Into sine n pi x by L. Sine n pi x by L. L is 5. Or you will be confused. No need to save one term, otherwise you will be confused. So you do one thing. You put everything first. You put here summation n equal to 0 to infinity, because in the exam you can do shortcut, no problem, if you are confident. But if I am removing this term, after some time you will not be recognized what I am doing. An cos a n pi t by L plus Bn sine a n pi t by L into sine n pi x by L. So this was my formula. So this same formula I have written here. So conventional method is that my for this type of equation, this will be my formula. Now A is equal to 3, L is equal to 5, and for Gx is equal to 0, Bn will be equal to 0. So these value Bn equal to 0, L equal to 5, A equal to 3, I can put here. So my equation will be available. So uxt will be summation n equal to 0 to infinity an cos 3n pi t by 5 into sin n pi x by 5. Okay. So this is my, I am going towards answer. Okay. So in that also, I can apply t equal to 0. So at t equal to 0, this will become ux0. That will be equal to this side. Cos 0 will be 1. So only this much is remaining. Summation n equal to 0 to infinity an into sin n pi x by 5. Understood? Now, what is the ux0? ux0 already given. What is that? ux0 is 4 sin pi x minus sin 2 pi x minus 3 sin 5 pi x. So that will be written here on the left hand side. For sin pi x minus sin 2 pi x minus 3 sin 5 pi x will be equal to summation n equal to 0 to infinity an sin n pi x by 5. Okay. So first note down this page, then we will go. Done.
Yes, sir.
Now I will check your skill. Okay. Now comparing on both sides. See, here it is sin n pi x by 5. So from there, n value here are n value 0, 1, 2, 3, 4, 5, dot, 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 up to infinity. This is the meaning of that. Okay. So now comparing on both sides, coefficient of different terms.
So 5, 10, and 50.
Yes. Okay. See how I can get pi x. If n is equal to 5, so 5 to 5 cancel, it will become sin pi x. So it means it is a5. How I can get 2 pi x? If n is 10, then also I can get sin 2 pi x. How I can get 5 5 pi x. So it means your n should be 25. So these terms will give you these coefficients. Okay. So by comparing them, I will get a5. So here I will get sine pi x. If I put n equal to 5, so then it will be a5. So a5 is 4 here. If I compare on both sides, so a5 is 4. A10 will be how much? Here a10 will be for n equal to 10. So a10 will be minus of 1. And then sine 5 pi x I will get for a25 sine 5 pi x. So a25 will be minus of 3. So these are the value. Okay. If I find nth value, tell me, is there nth value on left hand side? No. So an value will be 0. Okay. Hence, solution can be written as only these many terms will be there. What is your solution? Solution is uxt. Don't be confused from here. ux0 is not the solution. Solution is main solution is uxt. And uxt is what? Come to uxt. ux2 is this much. So now here you have to use which term? Only a5 term is there. Only a10 term is there. Only a25 term is there. Understood? So, and bn is already 0 here. Bn you have to take 0 because gx is 0. So this term I will not take. So you cut it. So why we are cutting? This is the reason. So only this much will be the answer. So from here, just a5 you have to take. For a5, it will be cos 5 pi t. Cos 5 pi t. A is also there. Understood? A value is 3. That also we will put. So 3 into 5, that will be 15. So a5 into a5 value we will put. A5 value is 1 now. So that also we will put. Sorry, 4. That also we will put. So, and into sin n pi x by L, in n you have to put a5, sorry, 5, 10, 25. So three terms will be there. So we can get the answer 4 into cos a n pi t. One second. A value is 3. N value you have to put. N value you have to put 5. Okay. Then it will become a5. And a5 is 4. Cos 3 will be the a value, pi t by L. Understood? L is 5 and here n is also 5. 3 into 5 into pi into t divided by L into sine n pi x by L. Sine 5 into pi into x by L. L is 5. Understood? So this will be my first term, and here A5 is 4, so I have already put it. Okay, next term will be A, or just wait for 1 second. This I will write A5 so that it will be more understood. It will be A5 into this much, and plus A10 into cos A n is 5 into pi into t, and what sorry, n will be 10 now, n will be 10, and divide by L is 5 into sine n is 10 pi x by 5. Okay, next term is A 25 into cos 3 into 25 into pi t divided by 5 into sine 25 pi x by 5. Okay, so now we will solve it. Now put the value of A5. A5 is 4 into cos 5 to 5 cancel, 3 pi t into sine pi x plus A10 is -1. So don't take plus, take it minus. It will be -1 into cos 5 to 10 cancel, so it will become 2. So 3 into 2 will be 6. 6 pi t into sine 2 pi x, and plus A25 is, again it is minus, so -3. -3 into cos 5 5 ja 25, 3 5 ja 15, so 15 pi t into sine 5 pi x. So this is the answer. Okay, so note down this. So this page you have done or not? This is already done now.
Yes, sir.
Okay, so go to next page. This page you note down. You have to go through all the problems what we have discussed today. Otherwise, you will forget the procedure. Okay. And verify this. This is your homework. Verify this by D'Alembert's formula. If you are not able to verify, please tell me. I will send you the verification. Okay. But you must go through it because it will give you the skill how to solve such type of problems. Done?
Yes, sir.
Okay, next. Now, actually, we have done a very simple. This is very simple wave equation we have done. Now we can go one step ahead. We can take here the damping factor. Okay, the complete wave equation is having all the forces. The complete wave equation having all the forces. What will be that equation? You must understand a square uxx. This term we always take, okay? There is no new in this, plus fxt. This type of force is known as external force. Means in the wave, in creating the wave, some extra force is also added. Suppose this is your string, it is going this wave, okay? But suppose I have put something here. Every time when it is going there, it is touching here. Some extra force is given to that, okay? And some dragging is also there. So with that, damping will be created. It is external force created, okay? So like this, so many terms we can add here. So many force we can add. So this is the external force I am adding with that string. So this is the external force I can add. That will be equal to UTT. UTT term we always take with time. With that, I can add gamma into UT. UT means del U by del T. This is del U by del T. So this term give you damping factor. Here gamma is the damping factor. So this is the damping force. Complete thing is the damping force. How it comes? By dragging. Suppose some wind is blowing with some force, so that will give you dragging. So dragging, damping force will be there. That will be single differentiation. So that will be gamma. Gamma is the damping factor. If this term is there, so it means damping is there. Now you can compare. We have taken undamped wave. Undamped wave means 1D undamped wave. Undamped means this term was not there. We have taken simple this term and this term. And our complete equation was this much. So this is very simple equation. No external force is there. No damping is there. Okay. And one more term we can add, restoring force. Restoring force will be just without any differentiation. It is positional. This depend upon position. Restoring force depend upon position. Damping force depend upon velocity. Okay. And external force depend upon acceleration. So we can write this. This here K is the restoring factor. And this complete force is known as restoring force. Okay. So if all the forces are there, then only it will become a complete wave equation, having all the forces. But problem is that we cannot solve this type of equation by our methods. It is very, very difficult to solve. Hence, we use numerical techniques. So you must know that whatever the problem cannot be solved by our mathematical method, we just go to numerical technique. In numerical technique, approximations are used, and those approximations are done again and again and then repetitively, so that we get accuracy in each step. Okay. And by having the computer 1,000 times we can repeat it, or 1 lakh times we can repeat it. So once we are doing it more repetition, we will get it correct answer. So in computer, it is not difficult to solve the such type of problem by having the numerical technique. But for a human being, solving the same problem 1 lakh time, it's very difficult. Okay. So we can say there, this type of problem, this type of means when all the forces are there. So this type of problems are very difficult to solve. So we use numerical technique method. Okay, in the numerical technique method, with iterations, you can say, means so many times we will solve it with many iterations. Okay, so with the help of computer, we can have more iterations and get correct answer. Okay, so this type of equation can be solved by computer only. So we will not go in that, but we must have knowledge why we are not taking these much. Okay, only one term extra we can add, that is the damping factor. So then that will become a damping wave. That we can add and we can solve. So I will show you the procedure for that also. But that also will become very difficult and it will not come in the question, exam. Okay, just only I will tell you the procedure. Note down this. Done.
Yes, sir.
Okay, so now I am taking 1D wave with damping force. Okay, so we can write such equation. So only damping force is there, mind it. In our simple equation was a square u double x was equal to u double t. So in that only damping factor you have to add, that's it. Such equation have the form. So this is the form of such equation. Okay, in that you have to add damping force. So damping force is gamma into ut. I already told you. This gamma into u2 you have to add. Ut means del u by del t. Okay, so this will become your equation. So here also because this side it is a function of t, this side it is a function of x. Okay, so we can write u xt, because u is this is the meaning of del u by del x square. So u will be written as pure function of x into pure function of t. This you have to put in this equation. This is equation number 1. Put in equation 1. So then actually this is a square del 2u by del x square. And this term I am putting here. So t is constant here. T will come out into double differentiation of x with respect to x. So that will be x double dash. Understood? Or should I write it in that term? Okay, so one way you can write, this is a square del 2u by del x square equal to del 2u by del t square plus gamma into del u by del t. So this is also the same form. Okay, So here double differentiation of x, I am writing x double dash, and t is constant, so it will come out. So that will be equal to in u double t means del 2 u by del t square. So del 2 u by del t square. So x will be taken common here outside because it is constant, and it will be del 2 t by del t square. So that will be t double dot, not dash, because it is with respect to time, plus gamma into del u by del t. Again x is common, into t dot, single dot. Okay, or I can write this equation completely: a square t into del 2x by del x square equal to x into x. Simply just I am writing x. It you can write it simply xt also. So that will be del 2t by del t square plus gamma into x into del t by del t. So this is my equation. Now I told you that we can have the variable separable. So for that, what you have to do? You have to first divide the whole equation by xt. So when you divide it, so it will become a square by x del 2x by del x square equal to 1 by t del 2t by del t square plus gamma by t del t by del t. Okay, now you see this side is pure function of x and independent. This side it is pure function of t and independent. Okay, so this can be possible only when it is equal to some constant, and that constant I am taking lambda square. Okay, so the same method we are applying here. So now what we can do here, you can take one by one. First you take this equal to minus lambda square, then you take this equal to minus lambda square. So we get 2 ODE, ordinary differential equation. Number one, a square by x into del 2x by del x square is equal to minus lambda square. So this will become actually here what we have done in the previous problem, this a square we have taken not from here, we have taken with this t. So you write it here because it will become a standard format. So then the first equation will become 1 by x del 2x by del x square equal to minus lambda square. So this will be x will be multiplied here, it will become del 2x by del x square plus lambda square x is equal to 0. So here x can be taken common, it will become fd. So this implies del 2 or you can write d square plus lambda square into x is equal to 0. So this is your fd. Now to solve such problem, we can solve such problem. Okay, so put fd equal to 0. So this is your auxiliary equation. We have done it already. So d square plus lambda square equal to 0. D will be plus minus I lambda. So with that, what will be the solution? So solution will be here. X will be, because x is the solution, x will be a cos lambda x a cos lambda small x plus b sin lambda x. and outside it was e to the power 0 into x, so that has become 1 only. So this is the value of x. Note down this. Previous page you also want, no? Note down this quickly. Done. What happened?
Done, sir.
Okay, this page also you complete.
Done, sir.
Okay, so now what is my next step? Now I have to take second equation. Second equation can be made by this portion with lambda square. Okay, so second ODE equation will be del 2 t by del t square, and it is 1 by a square. No, see, it is 1 by t also and 1 by a square also. This a square t, and from here also a square t, that will be multiplied with lambda square. So just I am writing del 2 t by del square plus gamma del t by del t plus gamma del t by del t is equal to a square t has come, sorry, a square t has come this side, minus of a square t gamma. So that will be coming this side. It will become del 2 by del t square plus gamma into del t by del t plus a square gamma into t is equal to 0. So this equation will become, t will be taken common and fd will be here. This is double derivative, so d square plus gamma into d, del by del t is d, and plus a square lambda into t is equal to 0. So this will work as fd. So now what is the solution of that? So for having the solution, put auxiliary equation. What is auxiliary equation? In that you have to put fd equal to 0. So d square plus gamma d plus a square lambda is equal to 0. So this type of equation you can solve by Sridharacharya formula. So here d will be minus b. B is gamma plus minus under root b square is gamma square minus 4ac, 4 into a square, divide by twice into 1. Done. So by this you will get two roots, m1 and m2. So once you have the m1 and m2, two different roots, so these are your roots. Because we are learning the method, correct answer will be taken when it is in the question. So t will be how much? T will be c1 e to the power m1t plus c2 e to the power m2t. So this is your t, this is your x, hence uxt will be x into t. It means you have to multiply both. So this will be a cos lambda x plus b sine lambda x into c1 e to the power m1t plus c2 e to the power m2t. So again here a, b, c1, c2, 4 coefficients are there. Understood? So to get them, you need 4 boundary conditions. So this is your solution of such type of problem. We require 4 boundary conditions to get values of 4 coefficients. Okay, note down this. So like this we can solve damping wave equation.